And looks like we're live. Okay, so good evening, everybody, and welcome back to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show. We hope you all had a great weekend. As usual, I'd like to welcome back Mike Powell and Paul Owen. Mike's from the PFO Observatory here in St. John, and Paul from the Moonshadow Observatory in Hampton. So let's click on the guys here. Hey, there's Mike. Good evening, Mike.
Howdy.
And Paul. Evening, Paul.
Hello.
Big hand.
Again,
Big hands. I got big hands.
You certainly do. All right. So on tonight's program, we're going to start first of all with a little brief view of what's happening in space this week, or over the last week, I guess. We're also going to have a talk. Paul's going to give us a talk on his Star Adventurer for astrophotography. And then something I received a lot of requests on lately is how to find the Starling satellites when they're passing overhead. And I get a lot of questions on that, so I'm going to take you to a website that I go to quite often to find out the information for you when you're asking about it. So we'll take a little look at that for a bit. For those who don't follow the page or follow it, the Starling Constellation Program is a project that was set up by Elon Musk and SpaceX to deliver up to 12,000 satellites in a low Earth orbit and to attempt to deliver broadband internet to the entire planet. The satellites are usually launched about 60 at a time, and as they are trying to achieve their final locations, they tend to follow each other across the sky. Within the first few days of launch, they are relatively close to each other, and they form what we call a train. We'll spend a little bit of time discussing how to find the information you need to determine where to try and catch the Starling satellites going overhead. Mike's also going to give us a talk on providing a review of his Pegasus dual focus motor focuser. I think that's what it was, Mike?
Close enough.
Close enough, okay. That works for me. Paul's going to provide us with another segment of Rosanna's fun facts as well. And then during our photo submission segment, which we got some nice photos this week sent in, we're also going to show a few from our stargazing evening the other night in the pristine dark skies of Fairfield, New Brunswick, just outside of St. Martin's.
Yes, I was reminded that it's Fairfield.
Fairfield.
Yes.
You will be reminded many times about that, for sure.
Thank you, Trudy.
Thank you, Trudy, yes. So sit back and enjoy, folks, and remember this is the live broadcast, so if you have any questions along the way about astronomy equipment, any type at all, this is the time to ask them. So I guess let's get started with a brief talk about what's been happening in space this week. So let me get started with that part. And first of all, I guess I'm going to do is share my screen here. I'll share this one. Nope, I don't want to share that one, do I? Here we go again. Hang on a second.
Lost in space.
Lost in space. Let's see this. See if I can bring it up anyway. Maybe I can't. Hey, yes, I can. Look at that. All
Very
good?
cool. Yeah, I like it.
Hey, cool. Okay, great. So NASA's next Mars rover is in the home stretch now. The launch of the NASA's Mars rover Perseverance, the life-hunting, sample-catching red planet explorer, is just a month away. The car-sized robot is scheduled to lift off atop a United Launch Alliance Atlas V rocket from Florida Cape Canaveral Air Force Station during a window that runs from between July 20th and August the 11th. Getting to this point has not been easy. Mission teams have had to prep the rover and rocket for liftoff while the coronavirus pandemic swirled around them, forcing the closure of many NASA facilities. But the space agency prioritized getting Perseverance to the pad on time while protecting the workers' safety as well, given that Mars missions launch windows only open just once every 26 months. Whenever the six-wheel rover lifts off during the coming window, it will land on February the 18th, 2021, inside the red planet's 28-mile wide or 45-kilometer wide Jezero crater. Jezero harbored a lake and a river delta billions of years ago, and Perseverance will use its 7 science instruments to characterize that potentially habitable ancient environment and look for evidence of the long-dead Mars life, among other things. Now, NASA's mission to Mars will include a helicopter. We can see it there. Can't see that image. Just try this image. Just a second. We'll close that one. Beep. Wrong mouse. Hang on. Here we go again. Technical difficulties.
Hello.
There we go. Hello. There we are. There's a helicopter. NASA's next mission to Mars will include a helicopter. And recently, engineers attached the hovering probe to the underside of the mission's rover. NASA's Perseverance rover and the Ingenuity helicopter are currently expected to arrive on Mars in February 2021. So that's pretty cool. First time they'll have a helicopter on Mars, on another planet. Hopefully it won't take off on them.
Kick up a little dust.
Yeah. Let's see if this one loads or not. Here it is. Okay, so watch this one back and forth. The SOHO and Heliospheric Observatory, Solar and Heliospheric Observatory, or SOHO, spacecraft recently made its 4,000th comet sighting. Now, SOHO is a collaboration between NASA and the European Space Agency and was primarily designed to study the Sun, but its location in space allows it to detect comets that get very close to the star. NASA and the European Space Agency collaborated to launch the Solar and Heliospheric Observatory, or SOHO, spacecraft back in 1995. Designed to last 3 years, SOHO was tailored to study the Sun, in particular by imaging the Sun's outer atmosphere, or corona, and the birth of the solar wind, a stream of charged particles that flows off the Sun and across the solar system. So it was designed to last 3 years and was sent out in 1995. Not bad, huh?
Bad at all.
Wow. But that work also gives SOHO a prime vantage point for spotting comets that dart perilously close to the Sun, it turns out. So there. Pretty cool, watching comets fly into the Sun. SOHO number 4,000. Next up, summer solstice. Summer arrived, of course, in the northern hemisphere on yesterday at 6:43 p.m. Atlantic time. The June solstice also marks the beginning of winter for those in the southern hemisphere. Solstice, or Latin for solstitium, means sun stopping. The point on the horizon where the sun appears to rise and set stops and reverses direction after this day. On the solstice, the sun does not rise precisely in the east, but rises to the north of east and sets to the north of west, meaning it's visible in the sky for a longer period of time. Even though most people consider June 21st as the date of the June solstice, it can actually happen anytime between June 20th and June 22nd, depending on which time zone you're in. The varying dates of the solstice are mainly due to the calendar system. Most Western countries use the Gregorian calendar, which has 365 days in a normal year and 366 in a leap year. A tropical year is the time it takes the Earth to orbit once around the Sun. It's around 365.242199 days long, but varies slightly from year to year because of the influence of the other planets. The exact orbital and daily rotational motion of the Earth, such as the wobble in Earth's axis, or called precession of the equinoxes, also contributes to the changing solstice date. And that's all I got to say about that part. Let's try one more. But during the solar spectacle known as an annular solar eclipse, which happened yesterday as well, actually it happened overnight, last night into this morning, the moon covered most but not all of the sun. During this type of eclipse, a bright ring of fire of the sun remains visible around the edge of the moon. The eclipse began at 12:45 p.m. Atlantic time today and will ended at 6:34 this morning. The crown jewel of the event, the ring of fire section of the eclipse, when the moon, sun, and earth lined up just so to create the brilliant effect, also known as the maximum eclipse, occurred at about 3:40 this morning. While not everyone around the world was able to view the event, it was visible either in its entirety or as a partial solar eclipse to potentially millions of spectators across the Democratic Republic of Congo, Central African Republic, the South Sudan, Ethiopia, the Red Sea, Yemen, Saudi Arabia, Oman, Pakistan, India, China, Taiwan, and the Philippine Sea. And Northern Australia had a front row seat for the stellar performance. Our next opportunity to see something like this is going to be June 10th, 2021 of next year, when the sun will rise, being eclipsed by the moon at sunrise. And that's all I get to say about, yeah, that should be really cool.
Yeah.
As the sun rises, the moon will start to eclipse it. And we'll get that for a couple hours anyway. So we'll get about a 70, I think it's a 72% eclipse here in St. John.
I wonder, I guess we'll have to look and see what the how far it'll be above the horizon when it starts to do that.
It just as soon as the sun pops above the horizon, it just begins to be eclipsed. So
the best place would be down by the water again.
Absolutely, yeah.
Where there's no fog.
where there's no fog.
There's no fog. Yeah.
Good one, good one. All right, let's close out these pictures and try to do it without closing out the show. Because I did before. All right, and I'm going to stop sharing here. Stop screen share. Perfect. Am I back? I should be back. Come on. There we are. Hey! Hey! It worked.
Yes.
Whew.
Welcome back.
I hate being in the spotlight. All right, so that's that segment. Who would like to go next, guys? Either Mike on your talk on
I guess
the
I'm up.
focuser? Okay,
Yes.
sounds
So-
good.
My topic is something that is not used. Apparently, we can't use that term anymore. It's called new to me.
Hang on a sec. Let me get click on you here. There we go.
I'm just going to slide this in front.
Okay. I'm still seeing Chris.
You are?
Oh, just sorry. My apologies.
Am I up?
You are.
You're up.
Okay. This is something that I recently purchased for myself off the Canadian buy and sell site. I was scooting along there, and I won't say how much I paid for it, but I got such a good deal on a new to me item that when he put the second one up, I bought it as well. And it's the Pegasus electronic focuser and the dual motor focus controller that I purchased for my scopes. Now, just recently getting into astrophotography, I found out how important it is to have a moto focuser. When you're reaching over, watching a screen and trying to adjust things with your finger as it shakes the scope, it's really hard to get pinpoint stars. This thing made all the difference in the world, and I just wanted to show it. The system itself comes with the focus motor, the controller, and all the goodies to attach it to just about any focuser you can think of. The L bracket comes with it. All of the screws, nuts, bolts, washers that will fit just about any focuser in the world. It comes with, if you can look down in here, there is a coupler that'll connect it to the shaft of your focuser, and it comes out and connects to the shaft of the focus motor. And all that is supplied with it. There's 5 or 6 different couplers, and one of them is definitely going to fit the focus that you want to put it on. It literally takes no longer than 10 to 15 minutes to install it on your scope. I put it on this particular focuser that I have because it's an SCT focuser, and I can literally take the whole works and swap it from one scope to the next just by unscrewing the focuser. The good part about it is you can adjust the rough focus with the mirror on the scope. Then you can go to the Crawford focuser on the back or Crayford focuser on the back and get that fine tuning that you really, really need. And this thing makes the beautiful tiny steps ever so small. I'll just show you quickly how you can whip this thing together. It's already on there. So the easy part to connect it is one RJ12 cable. This connects on. See if I get this the right way here. There we go. Simple RJ12 cable plugs into the controller, plugs into the focus motor, and it runs on 12 volts. So you take your 12 volt plug it in, and your focuser is in business already. And all you've done is basically connect the motor to the focus controller and connect it to the controller and the motor. And then you give it power. So if you watch ever so gently here, I can manipulate it by hand just by turning the knob. And it's ever so small movements on the shaft itself. So you can get the finest of focus in and out. And you can still do it manually. Now, one more step, if you're trying to get away, that's the whole reason you bought a motofocus system to begin with, is to get away from touching it manually so you don't shake it. Then this puppy comes with its own software supplied by Pegasus. It's just a USB controlled. Plug it in, you connect the focuser, and all you have to do is push the button on the screen, and you'll see the focus motor going again, in and out. And you can change the steps on this. For every time you push the button, it'll do 15 steps of the stepper motor, 50, 100, or 250. So you can do a rough focus and then pinpoint it right down to a super, super fine focus. And it's all controlled by your mouse. You never have to touch the telescope. And you can see how fast that the 10-to-1 knob is spinning when you're focusing. That shows you, it is moving. Sometimes you look at it and you go, is that thing really moving? But it is. It's just such a fine focus that it's going to bring your stars in pinpoint. The third item that comes, or another piece that comes with this, and I haven't really gotten deep into the electronic focusers and astrophotography and stuff, but it comes with a temperature probe that just plugs in to the controller as well. And you can monitor the ambient temperature right beside your scope, right beside your focuser, or up near your corrector plate or your lens or whatever. But it allows you to have temperature compensation that's written into the software as well. So as your night cools off, maybe your focus might change a little bit. Paul, you probably know better than I would because you've handled this a lot more. But you may get a focus change, and you can actually set it up so if you're at the same temperature during certain parts of the year, you can set your focus for that temperature as well. Is that not correct?
Yeah, basically what it's designed to do is that if you're pre-programming it into your regime, then you can have a refocus every hour, because what happens is, as you know, being in the Maritimes, we have hot days and cold nights. So the focus can shift just based on, the metal,
expanding and contracting, so to speak.
Yeah, expanding and contracting. So what it is you can tell your focuser through your software that every hour to refocus, because that's about, or every degree of temperature if you want. Like
refocus, yeah. It's really cool. Now it's all ASCOM compatible as well. So I don't necessarily have to use the Pegasus software to run it. If I use SharpCap, it shows up on the SharpCap software, gives me full access to the focuser. Astrophotography tool, again, because it's ASCOM compatible, don't have to use a separate piece of software. I can just keep APT up and run the focuser all night long. And I'll tell you, it made a heck of a difference in just me taking my photos, because again, now I don't have to touch the scope to focus it, and I don't have to wiggle back and forth and try to watch the screen and figure out if that dot's getting bigger or smaller. And I love the convenience of putting it on this smaller SCT focuser, because now I can just take that off and stick it on any of my SCTs, and I got a moto focus for every one I want to use it. Anyway, that's my little show on the Pegasus focuser and dual. They call it a dual focus controller because it's set up to either run stepper motors or DC motors. If you change the cable and change the wiring, it'll actually run on just a DC motor, which is kind of cool too. But the stepper motor you buy separate from the controller. Now Pegasus has a package out where you can plug directly into the focus motor and control it. But it doesn't give you the option, I guess, of using it manually if you want to still. It takes that option out, where this dual focus controller allows you to use it without having to use software if you choose. So I love it. I think it's great. So like I said, I like it so much I bought a second one.
Question for you, Mike. So the software that comes with it, and that system there, is designed to work with those power boxes.
Anything.
So down the road, so down the road, if you want to get a Pegasus
Ultra power box or whatever, it's designed to connect right in. Anything Pegasus, it's made to go with it, including the separate dew heater controller if you want, or the ultimate power box, or all the other neat little things that they offer in Pegasus. It's good quality equipment. It's buying stuff off aftermarket, you expect to get something used. And, sometimes this guy took really good care of this system, number one, and I very much appreciated that. But it is very robust. Like, it's built to take knocks and bangs and bumps and all of that stuff and keep on ticking. I was really, really impressed with the quality of it. for what you're paying for, and quality means everything.
Yeah, absolutely.
You just can't walk away. It's quality is everything, and I was so impressed at how well this focuser works. I run it remotely from up here in the garage when I'm running down to the observatory, and this thing just smooth as silk, and you just can't beat it.
Yeah,
I'll never go back to manual focusing again, as far as at least when I put a camera in. When I go to do normal viewing and stuff, sure, but it's so nice that once you add a camera, and I'm just getting into this, that you really have to have a moto focuser of some sort, so that you can do that focusing without touching the telescope.
I guess the other advantage too for you is when you're in the observatory, or when you're in your building
control center.
Yeah. So now when you do your live stacking, you don't have to go outside to focus.
No, not at all. And it is. It just makes such a difference when you're trying to do photography. I've seen you got yours, and I thought, okay, I can get good focus, but I didn't realize how bad my focus was until I got a moto focuser.
Yeah.
How's that?
Yeah, it makes a difference. It really does.
Makes all the difference in the world. And like I said, it's so simple to put together. Pegasus makes it as easy peasy to just bolt everything on. They give you all the parts, pieces. It's all there, and it's so compact. The only thing it doesn't have is I use double-sided sticky tape to hold the controller on here, because you can mount the controller down on a tripod or hold it in your hand so you don't get the vibration when you're trying to do a manual focus. Yeah, I just double sticky taped it to the side because I'm going to use it, remotely, and that's it.
What did it add much weight?
Virtually weighs about less than a can of pop.
Oh my goodness! Wow.
I think my 40 millimeter or 50 millimeter 2-inch eyepiece weighs more than the actual combination of focuser, controller, and the mount itself.
Wow.
So they're very light. Yeah.
That's fantastic.
There you go. That's the Pegasus focuser in one shot.
Thanks, Mike. Any other questions before we get away from Mike? Richard says you can also set the step counts to return to the same focus the next time you use the scope.
Every time, yeah.
Okay. So I wanted to draw special attention to over Mike's left shoulder there.
No, point at the ceiling here.
Yeah, there he is.
There he is. And there's a match going on in the back over Mike's top left shoulder with Darth Vader and Stormtrooper.
They're social distancing.
So what's in the Stormtrooper's hand, Mike? Is he?
If Vader gets too close, he blasts him.
Is he passing him a mask?
No, he shoots him. Stay away or die.
Yeah, nice to get
fantastic.
It could be a rebel in that suit. One never knows, right?
Nice to get the wind there blowing right in the cape too. That's pretty cool.
I think that looks so cool. Yeah. I really like it.
Thanks a bunch, Mike.
No problem.
Okay, so maybe what we'll do next is, Paul, you want to do your Rosanna's fun facts, maybe?
Sure.
Okay, let's get you on the camera here. And should be good to go. Oh no, hang on. Get you on Facebook here.
I gotta wait for you. Remember?
Yeah, you gotta. Oh yeah, you gotta wait for your intro. But are you gonna bring up? You tell me when you're ready for your intro.
I'm ready.
Okay, are we ready for the intro?
I think so. Hold it. Am I sharing?
Not yet.
Okay, I'm ready whenever you are.
Okay, we'll see you. Uh-oh.
Hey!
We got it. We got it this time. All right. Well, welcome back, Rosanna. We missed you last week, and so she's got a really good fun fact for us this week. And this week is kind of an interesting one, really. I'm just going to I'll get my thing here, and I'm going to open up, and I'll tell you what she had written. So she says, time is relative, and certainly the world situation is messing up our man-made construct of time, especially on grocery day. As time and days get a little mixed up throughout this pandemic, my inbox is filled with many articles about COVID-19. Some are about how long it will take to create a vaccine. And the estimates range from 12 to 18 months in the best case scenario. So we will have orbited our sun and then some before the science of the vaccine will be definite. A whole Earth year will need to pass. So this seems like a really long time, especially since we're waiting for, for life to return to normal. But it may for everyone. Excuse me. Oops, I pressed the wrong button there. So it may for everyone help feel a little better if we do some hopping around our solar system, and we'll compare how long it would take to spend 1 year or one full orbit around the sun on another object. So if you were, I'm going to show you a little, and I'm going to blow that up hopefully. So this is a scale. So that big purple blotch in the center, we're looking at the sun. And if you look at the scale on the bottom, if you go all the way to the left, you see Mercury, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. So basically our solar system. And then you keep on going further on out, and then you see a whole bunch of other discovered worlds out there. So let me just find out where I was here a second ago. Solar system compare along. Okay. So if you were waiting for a vaccine on Eris, and Eris is right here, which is 96 astronomical units from the sun. To put that into perspective, if you don't know what an astronomical unit is, it's the distance that we are from the sun, how far Earth is from the sun. That's 1 astronomical unit. So Eris is 96 astronomical units away. So that's quite a little ways. So if we were waiting for a vaccine on Eris discovered in 2005, it would take 558 Earth years to orbit. If you were on Sedna, which is this one right here, it would take 11,406 Earth years. And if you and that was recently discovered, by the way, in 2018. And aptly named Far Out Object, which is 120 astronomical units, so that's one all the way to the right. The furthest out object so far, it would take just under 1,000 Earth years to complete the orbit. So if after looking at this chart, you're wondering why the TNO, Mike, the TNO is?
Neptunian orbit. You had to say that, didn't you?
That's a hard one to say. So the trans-Neptunian orbit. So basically, it's the fact that particular planet is on a elliptical orbit, and so there's certain phases that, depending on where you are on the orbit, it takes an extremely long time to get out there, apparently. So the reason for the lengths of these orbits not to follow in order is due where the object is on its orbit. So you see Kepler's third law. And the distance in the diagram are the current distance, not meant distance, and the astronomical measurement varies greatly between periphelion and aphelion. So Sedna's, for example, is 937 to 76, even though at times it is closer to the sun than Eris. So Sedna's orbit will take much longer. So again, depending on how the orbit is going around the sun. So though it might take less time for a 1 year vaccine on Venus, which is 225 days, and on Mercury, it would only take 88 days. So no travel is allowed, so I'll take Earth. The weather is better, and a year no longer seems like a very long time at all. So there you go.
Absolutely.
Yeah, it's so interesting to put that in perspective. So a year, for those people who think, I can't take a year, think about that if you're way out, too far out. So that is this week's.
Rosanna's Fun Fact.
Awesome.
I love that every
time.
much, Yay! Thank you, Rosanna.
Awesome.
That was awesome.
Thank you.
Thanks, Paul.
Yeah, that was great.
Good stuff. Okay, so maybe we'll go to photo submissions here quickly, because I just have a few photos to show. And then, Paul, I'm going to get you right back again to do your review on your Star Adventure. Because after that, all we've got is a bit of a talk on Starlinks, so that won't take very
Well,
long.
actually, before we get into that, are you going to talk a little bit about your contest sometime tonight?
Oh yeah, that would be an idea too. So yeah, we do have there is a new contest coming up. It's called Shoot the Moon. It's the contest that I've run a number of times now. So all I ask you to do is to take a photo of the moon, send it into my page, my Facebook page, or if you're on Instagram, you can send it into Instagram. I'll watch for them there as well. It has to be a new photo of the moon, something taken from tonight until July the 11th. That's the date of the contest will close. Now the photo can be any quality. You can use a DSLR, a tablet, your cheapest phone that you have. Doesn't really matter. Take a film shot and take a picture of the film. It really doesn't matter the quality. I'm not judging any of the photos. All entries are accepted. If you like and share the post, once you see the post up there, you'll get a second entry. And of course, that's just to get the word out there that the contest is ongoing. Last time around, I had 172 entries for prizes, which was fantastic. So I have 3 of John Reed's books up right now. John Reed is an author, local author in Nova Scotia, and he has the 50 Things series of books. One's 50 Things to See with the Telescope, 50 Things to See on the Moon, 50 Animals That Have Been to Space. So one of the prizes is going to be the 50 Things to See on the Moon book, and there's a workbook, activity workbook that they kind of complement each other. So that's going to be one prize, the 2 of those. And then John's 50 Things or 50 Animals That Have Been to Space. That's a third prize or second prize, which is produced by himself and his wife both. And I want to thank John and Jennifer both for those prizes, donating those prizes to the contest. Thank you very much. And all of John's books are available on Amazon or Indigo, any of those fine bookstores out there. Also, I've got the book Night Watch by Terence Dickinson, which is really probably one of the best beginner books that you can possibly buy for learning about stargazing, astronomy. It has some really nice detailed maps, star maps that fold out when you use a red flashlight. They kind of pop out at you. It's spiral bound, so it opens up really nice and flat if you want to take it outside with you. And then the last prize is the book called Deep Sky Wonders by Susan French, and it's a great book. Describes all of the deep sky objects that we normally see in our night sky throughout the seasons, and at the very end of that book there's also another big set of star maps. So those are the prizes that are being offered. The total value of prizes is about $150, so not a bad little package. And if I get 100 entries on the contest, I'll add another prize. And then for every 50 entries after that, I'll add another prize. So we've got lots of time to get your photos in. Again, doesn't matter what the quality is, just go out and snap a photo of the moon, and the idea, of course, is to get you outside and be looking up, right? So that's the contest coming up. Again, if you wanted to submit them through Instagram, or you can submit them through Facebook. Either way, I'll accept both. And the contest draw will be on July the 12th. So lots of time yet to pick it up. Tonight is our 18-hour moon in the sky. So if you're out tonight at sunset, you should be able to pick up a very thin crescent moon out there. I'll even count tonight's shot because the contest did start today. So thanks, Paul, for reminding me about that.
Yes.
Okay, and let's go from there to just a few photos that I've got available. So let's bring up my file here again. I guess I'm going to have to share my screen, aren't I? Yeah. Look at that thing that's going to go flying through there. We'll just ignore that. All right, let's see what we've got. So I got this one from Chris Burke. Right here. And Chris sent it to me, said, hi there, hope I have the email correct. I just wanted to make sure, or I wanted to forward along a quick snapshot I took of the Milky Way last night. This was taken with my cell phone, a Galaxy S20, using Pro Mode. The exposure is set at 30 seconds at an ISO of 800, taken around 3 a.m. on a small tripod. It turned out surprisingly well for a phone camera. The image is facing almost due south to capture the galactic center of the Milky Way, which is partially visible to us at this time of year. So he said I'll be trying more of these with my DSLR soon. So
he also has Jupiter and Saturn in there.
He does, yeah right there.
It almost looks like Trudy's trees.
It does look like Trudy, yeah.
Maybe he was in the background down there.
He might have been. There's lots of space.
Yeah, there is.
Tim was saying he thought he heard something in the woods, so maybe.
Yeah.
Yeah, could have been.
What a nice detail for a cell phone.
That's
Beautiful.
fantastic. You can see the prancing pony in there.
Yeah.
And you can see the large Medallic in the cloud.
Yep, this is the Sagittarius cloud there, yeah.
Sagittarius cloud, I'm sorry. Yeah.
There's Sagittarius itself, yeah. So really nice capture for a cell phone. They're getting really well. And if you get it on a tripod, of course, that's going to help stabilize it a lot for you too, right? So, okay, so let's get out of that picture. And oh, hang on, I'm going to make sure they're coming up on Facebook too, are they? Yes, they are, I guess. Okay.
Yep.
So let's go to a few that Tim Libby sent me in. Here's Tim's capture the other morning.
Oh, Venus.
Yeah.
The moon and Venus.
Well done.
Venus.
Very nice.
Very well done. Yep.
So
Very nice
that was
capture.
through an eyepiece, was it? Must have been.
Tim says, hang on, there's notes here. Took these pics Friday at 5 a.m. or so. Skywatcher 200mm Dobsonian. So an 8-inch, I guess. Moon pics with Orion Sirius Colossal 25mm.
Yeah.
And then he has Saturn and Jupiter moons here too with SV Bony 6mm eyepiece. A Samsung Galaxy S8 camera with an XYZ phone adapter.
Very nice.
So pretty cool.
Yes.
Here's another one he's got along with it. So a little bit more clarity there, higher contrast. But look at the nice little crescent of Venus, eh?
It was so cool to see them both crescent like that too.
Wasn't it? Yeah. And it was so bright, eh, Mike? That popping out like that.
Bang.
Yeah. Unreal. Let's get the third one here, I guess, too. So here's just the crescent itself of this must have been just before, I guess.
Before it popped out, yeah. And it was like that. It was there, not there, and then bang, it was there.
Yeah, amazing. He sent this one is, I believe, his Saturn shot. So that's through the 8-inch.
Yeah. You see the moons.
You can see the moons, yeah.
You can, yeah.
Cool. And here's his Jupiter shot, I believe. With the
Yes.
moons all lined up, yeah. So I mean, that's what you're going to get through a nice small telescope too, right?
You can always tell when it's going through a reflector, right?
Yeah, you can, can't you? Yeah. Yeah.
I love the diffraction spikes. I think they look great.
Yeah. Great job. Thanks, Tim.
Yes.
Appreciate that. And Chris as well, thanks. And don't forget, folks, that you can send in your photos, if you like, to SundayNightAstronomyShow@gmail.com. It's all one word. And we love to get your photos, and we love to feature them up on our program. So let's hop out of them, and we're going to go back to stop sharing. Andrew says, "Sorry, I'm late. Father's Day supper." Good for you, Andrew.
Hope you had some lobster.
Yes, sir, for sure. All right, let me close that out, and I'm going to give this screen over to Paul now. Paul's going to give us a bit of a review on the Star Adventure.
Well, I am, but before I do that, and I kind of had an ulterior motive for you to talk about your moon contest, because I wanted to read a little passage out of one of the books that you're going to be giving away, which is the Night Watch book. And I was reading this. I've had this book for a long time now. The first edition of this came out back in the early 80s. And this particular edition that you see now was done 22 years ago. So the information on it is still relevant today. And that's the nice thing about astronomy, is the information never gets, outdated. The only thing that changed, whoops, I'm sitting on my keyboard pad. Hopefully that didn't do anything. The only thing that changes is the equipment to which we acquire some of these pictures, and of course some of the discoveries. But there's a little excerpt in this book, and it's written by S.P. Langley, and I think Terrence put it in the book because it's when I read it, I thought, when I first got into astronomy, I couldn't get enough information in books, and lots of times once you get into it, I've been playing around with this now since 2013, so it's been 7 years, and I find you get so wrapped up in the technology and in trying to improve certain things, you forget about the romance that brought you to the hobby in the first place. So a lot of these books, when you first start reading them, especially in the forwards or at the beginning of the book, they really set the tone for what they're trying to teach you in the book. So I just want to read this little thing because I thought it very inspiring. So it's called Discovering the Cosmos. We are voyagers on Earth through space as passengers on a ship. And many of us have never thought of any part of the vessel but the cabin that we're quartered in. So I imagine a world where a thimbleful of matter weighs as much as Mount Everest. The gravitational pull of a surface of this celestial body is so enormous that a human visitor would be crushed instantly by his or her own weight in a puddle no thicker than an atom's nucleus. Now consider a planet whose sky is ablaze with fireworks of stars being ripped into gaseous tendrils by a bizarre gravity funnel. There can be no living creatures in this corner of the universe, for the region is perpetually bathed in unthinkable doses of X-ray radiation. Envision a planet cloaked in a choking blanket of carbon dioxide, laced with sulfuric acid rain. Here it is so hot that the lead would be convenient liquid to use in a thermometer. A human explorer would be simultaneously incinerated and asphyxiated in this hellish environment. Then there is a realm where two suns illuminate the cosmic landscape. The solar twins waltz in a deadly gravitational embrace with millions of tons of gaseous star stuff flowing between them every second. The tug of war will end in an explosive destruction of one of these stars, reducing and nearby worlds into cinders. All of these alien vistas exist. The dense supergravity object is the collapsed core of an exploded star known as a neutron star. The gravity funnel is a massive black hole that is believed to be lurking in the center of the Milky Way galaxy. The carbon dioxide hothouse is Venus, the nearest planet to the Earth and the brightest object in the night sky after the moon. The the twin sun system is known as Beta in the constellation Lyra, seen overhead on a midsummer evening, is actually this time of year. In a universe of 1 billion trillion stars and unknown trillions of planets, the imagination withers into any attempt to grasp the true diversity of the cosmos. So that is an amazingly in-depth thought about what is out there. And when you're actually looking through this Night Watch book to look at all of these things that he's talking about, each page is full of those kind of that kind of information. And so when you're looking at it, it's not just a point of light in the sky. Oh, I see it. Think about all of the stuff that was just written in that little passage. And that's really what's truly exciting about looking at the night sky. So anyway,
it's awesome, Paul.
Okay, so besides that, let's move on. Okay, I'm going to show you my star adventure. It's pretty heavy, wasn't it?
Well, I mean, to hear you talk about something other than astrophotography, I was like, oh, wow, what's this?
That's what I was thinking.
Who is this guy? Who is this guy?
You did mention to look at the pictures, though.
He did, yeah.
Oh, fun fact.
But when I read that, it brought me right back to why was I, when I looked at the sky as a child, what was I thinking? And here I'm reading this and I'm thinking, that's what I should be thinking when I go out there. Never mind the equipment, never mind, it's going to be hard for me to talk about this thing now. But I'm going to.
I know.
All right, so I'm going to turn my camera so you can see it, or try to. There we go. And I'll pull it over here.
Just want to check with people out there before you start, Paul. Just want to see if is anybody seeing anything choppy on the video, or does everything look okay? Mike, you're seeing choppy or anything?
See mine on Facebook.
Okay, on Facebook, yeah.
Okay.
Okay.
Are we good?
I guess we're good. Yeah, go ahead.
Okay. All right. So basically, what I want to talk about, just very briefly, is what we call the Skywatcher Star Adventurer tracking system. And what it is basically, it's a system that's designed that you put your camera up here. because this is just basically a ball head mount that you would put on a typical tripod. Or you can mount a small telescope on these. And what it's designed to do is to track the sky as the Earth rotates. So as the Earth rotates towards the west, everything appears to be coming from east to west, and we're actually traveling from west to east. So when we're taking pictures of something more than 30 seconds in a camera, if you don't have one of these, then your stars are going to start to trail. You're going to get lines on your stars. So that's why a lot of people call these star trackers, is because then you can actually take pictures of the sky, 2, 3, 4 minutes. And not get any of those star trails. So because of those longer exposures, well, then you can certainly get way better pictures. And we were out to a little party we're going to talk about a little later here the other night. Not a party, but a gathering of astronomers looking at the sky, which was a party. And I took this with me, and I was able to, for my first time ever, take a picture of Rho Ophiuchus, which is a star complex system right around the star Antares, which is just west of the southern portion of the Milky Way. And all I could do before was get like 30-second shots, maybe if I use a really wide lens, if I want to get a little closer. Now I'm down to 15 seconds. Well, I was able to get 2-minute exposures with this without any trouble whatsoever. All you have to do with it, there's a little polar scope right here in the back. Just like when you get a regular, a nice high-end mount, they've got what they call a polar scope in there. So you look up here and line it up with Polaris, because it is a German equatorial system. And once you've got that lined up on Polaris, then that's your setup. That's all you have to do, other than balancing your scope or balancing this with your camera, like you would a regular mount. And then from that point, you just do everything else from here. So I'll just take my ball head, and I can spin it to wherever I want. So I can put it at any part of the sky. And I very rarely have to change anything here. If I have to, I can certainly unclutch it. And then I can turn my scope, or I keep calling it my scope, but my camera anywhere I want to. So when you buy these, there's two versions of it. There's the Skywatcher, or Sky Tracker, which is just basically this piece here. And then there's the Sky Tracker that's designed for astrophotography, which is this piece here, plus the wedge, plus the bar and the counterweight. So all the things you're going to need for larger things that you're like, larger, longer lenses on your camera, or if you're going to use like a little 60mm telescope, that kind of stuff, it'll handle it no problem. On the side here, there's a little button that you spin. So depending on what you want to take pictures of. So if I want to take a picture of the sun, then this is a little tracking button. I can actually track in the solar speed, how fast the sun moves. If I want to do pictures of the moon, I can switch over to lunar tracking. Or if I wanted to do what I did the other night, I just use sidereal tracking. So it's got all that different tracking systems built into it. It's got a little cable that comes and you plug it into your camera. So you can this will actually control your camera and take the pictures for you if you want it to. It runs by, it just runs by 4 AA batteries up here. And you can go out 2 or 3, 4 nights on 4 AA batteries. It's so efficient. It's unbelievable. What else can you do with? Oh, yes, it does have a guiding port on it. So if you want to get into guiding and, do 5, 10-minute exposures, you can do that. You can set up a guide system into it. And what else can I tell you about it before? Oh, yes, it's set up for time lapses. So if you want to do time lapses of the Milky Way coming up, or sunrises, sunsets, maybe whatever you want to do a time lapse of, you can actually set this up and it'll go through all of your sequences. And at the same time, instead of just being stuck on one part in the sky, it actually it'll actually move you over all the way to 90 degrees and then start bringing you back and go all the way over to another 90 degrees and then start bringing you back. So your time lapses not only will look great, but you'll also have a nice panning effect with it too. And that's built right into this as well. So other than that, that is very, very light. It's easy to carry around. I just put it on a tripod, and you can put it on a Manfrotto tripod if you have one. So they're really, really easy to hook up, easy to take. So if you're going to long places where you have to walk a little ways, there's not a lot of weight to them. So So that is called the Skywatcher, Sky Adventurer. The newer ones now, instead of being red, because I got mine a few years ago, the newer ones now are green, or white rather, with green lettering. There we go. And I don't know what more to say other than it works extremely well, very reliable, and I've had a lot of fun with it. And anybody who's getting into astrophotography who doesn't want to get into buying a telescope and a mount and all this other stuff, if you already have a camera now, you can start into astrophotography and get some amazing results for under $500. So
Yes,
that's my story on Skywatcher Star Adventurer.
Excellent. Hey,
Yeah.
Paul.
All right. And I'll
But a nice little package to be able to get out and enjoy the night sky with. And,
Absolutely.
And a nice portable package for sure.
It is indeed.
Okay, I guess the last part of our talk tonight is just going to be, where are we at for time here? We're running about 9 minutes.
We got 10 to.
Okay.
Lots of time.
Okay, so we should have enough time. Just to, what I wanted to do was just, I get a lot of comments, or a lot of questions on, let me click on myself here, on Starlink. Yeah, so the Starlink satellites that are passing over us quite regularly now, and a lot of people are asking me, like, how do I find out when they're going over, or are they going over tonight, or what time tonight will they go over, and what direction will they be coming from? So I was hoping to be able to offer just a quick, like, 2 or 3 minute tutorial on a website that I use a lot. Now there are many different links that you can follow. There's one called Find Starlink, where you can download that app, and it'll show you standing on the planet basically, and where they're going to be passing over your head. But that's good for that particular night, but it doesn't really get into other nights and other satellite launches. So there have been, I guess there's been 8 launches now, or 8 launches. Number 1 coming up next week will be launch number 9, but it's actually called Starlink 8. So let's just take a quick peek anyway, what I do when I'm answering questions when people are asking me that. So I'm going to have to share my screen, I guess, first of all. And I'll share this one. Hopefully you'll get this right. Oh yeah, I'll kind of move it. Let's see, just a second. And where are we at? This one. See, that pops up. Let me bring it over here. Hey, there we go. Can you see that?
Yep.
Okay. So all I did was I've got the page loaded here. It's called heavensabove.com. Okay, and this is the page I use quite regularly. I know the other guys use it a lot as well. I find I'm old school because I like a website rather than an app. But there are lots of other apps that are out there too. There's ISS Tracker. There's a couple by NASA, but this is the one I use the most often. So what I've done is I've just blanked out the page, and I'm going to go from the start here. So what we do is we go to Heavens Above, and we look up at this top right hand corner. It says user anonymous. That doesn't matter. You don't have to log in to get the information, but it says location unspecified. So if I click on unspecified, it'll bring me up a place where I can put in my location. So here we are out in the middle of the Atlantic Ocean. We don't want to be there. So all I do is come down to this part where it says enter place to search for, and from here I'll just type St. John, where I am. It's already been there, I guess. So St. John, and I'll click search, and it's found St. John County, New Brunswick, Canada, which is where we are. There it is, shows it up on a Google map where the location is. It even gives you your latitude and longitude and your GMT time. We're at -4 right now, of course, for daylight savings. So at the bottom of that, I click update. So now that I've clicked update, it comes up as location St. John. So from there, I would save that as my favorite, or bookmark it, so that I know I don't have to go back and do that next time. Okay? So from here, what I do is I look down this list, and there's a pile of stuff in here, all kinds of information that we can look at. There's solar eclipses, interactive sky chart. There's a sky chart itself, sun, moon, planets. If I click on planets, for instance, it shows us still from St. John, the right ascension declination, how far they are away from the sun, their brightness, when they rise and when they set, what their altitude is right now at this time, and I can change that date and time right along here in this top toolbar, and I can just update it or reset it to now afterwards. I can also see when the planet is going to be in opposition. For instance, Jupiter is going to be in opposition on July the 14th, which means that we'll be between the Sun and Jupiter on that date. So that's when Jupiter's going to be in the sky all evening long. Saturn is July the 12th or 20th, so just a week later will be Saturn. So perfect viewing for Jupiter and Saturn throughout the summer this year. Mars is going to be at opposition in October. So this is just some of the planet stuff that's in there. And all I can do is change the date up here and pick another date. So if I want to say, is Venus up in our evening sky in November, I can just scroll ahead to November and pick it out, and I can see here when it's rising and setting. So lots of information in here. But then if I go back from planet summary, I want to go to the ISS part that we were talked about. So here's the ISS. Here's the Starling passes. So if I click on Starling passes from all objects from a launch, and what we've got right now is a Starling placeholder. I think I might have said that back here. Did it? No, they don't have it there. Okay, so they put what they call a placeholder in place. So this launch isn't taking place until June 23rd. So this is where they believe the Starlings are going to pass. If everything goes well on the launch, this is what they've calculated out for it to be. So let's pick Starlink 9 here on June the 23rd, and we'll click on it. And once we click on it, we come up to a nice overhead map, star map. So it's and these times are very, very accurate. If it says 22:15 and 15 seconds, that's when you want to be looking in that direction. So we see that it's going to pass from the northwest over to the northeast, but at a very low part of the horizon, right? So only about 10 degrees up. And if I click back here, I'll see that. The brightness magnitude 5. So when you have a higher number, that means it's going to be a dimmer object in the sky. The lower the number, the brighter the object. Even when it gets into a minus, it's much brighter. So at a magnitude 5, that's going to be about 2.5 times as dim as Polaris, or about 2.5 times 6.25 times as dim as Polaris. So it's not going to be very bright. It's going to start at an altitude of 10 degrees at 22:17:00 out of the northwest. The highest point will be at 22:17:38 at 11 degrees altitude in the north, and then it'll end at 22:18:17 at 10 degrees in the northeast. That's the visible portion that you'll see it. So if I click on the next one, you see June 23rd, here's 4.6. Well, because it's a little bit brighter, again the number is lower, so it's brighter. It's because it's a little bit higher altitude, 19 degrees. So let's click on that one, and we can see it's just a little bit higher, but it disappears quicker too.
Yeah.
So we also have to consider what time is daylight. It's almost 11 o'clock now before we get into twilight, right? Before stars start really popping out. So this time here, 22:17, yeah, we'll probably get it, but we might not even get it. That's part of the reason why the brightness is so low. But let's scroll away from Starlink 9 and look at what's happening now. Starlink 8, which was launched back on June 13th. So if I click on June 13th, here's our pass tonight. What's happening tonight? Well, all these Starlinks are passing over, but look at the time of day. 2:35, 2:39, 2:44. Okay, so that's early in the morning. Not much good for us, right? 4:16, unless you're getting off work at 11 and you want to go out that part of the evening, sure, great. But here again, all we have to do is look at these, and if I'm looking at Starlink 8 for this particular day, let's take this one. Okay, so we've got one at 2:42:56, 2:43:04, so only 8 seconds difference. 2:43:08, 4 seconds difference, and then they start to split up. See, that's 19 seconds, and then we're into 14 seconds. So they're getting farther and farther spaced apart because they've been up there longer.
So, Chris, can I ask a question?
Sure, please.
Are these all the individual Starlinks satellites in the train?
Yes, they are. Yeah. So everything from Starlink 8, that launch of Starlink 8, they're all listed here.
Okay, so the number at the end, the 1459,
Yep.
those are identifier numbers.
Exactly. Yes. Yep. And some of them are magnitude 5.1 because they're
Right.
only at 12 degrees altitude. Again, the ones that are higher are going to be a lower magnitude, which means they're going to be brighter as well. So let's
Right.
take this one, for instance. There's June 24th. We'll just pick one. June 24th, 4.6, starts at 2:43:08, 19 degrees up in the sky, east-northeast, and then its highest point will be at 19 degrees east-north, so it's still going to be at the same altitude. And then when we stop seeing it, it'll be at 10 degrees east-northeast. So we click on that one. There we go again with our map. Look at that, little wee piece of sky, very little. So almost not even worth seeing, right? And if we can look back at the time here too, because if we start at 2:43:04, we stop seeing it at 2:43:50. It's not going to be very long.
Yeah, less than a minute.
Yeah. So if we go click on that again, and we can also go to this thing called ground track. If we click on ground track, there's our path. So there's a better idea. I like that better than I do the sky view as well, because this gives you a real good feel for where it's going to be passing across your location. Of course, in our case, it's St. John, so we'll be looking out to the east, southeast, and east northeast. So let's go back again, and we're going to. The other thing we can do. Okay, so there's no real good passes with Starlink 8 on this day. We'll go to Starlink 7. Hey, there we are. Now we're into some times that we can probably look at. So here's 9:51, 9:52. Still a little leery, but you can see how it flows, right? And you've got all of these launches here available to you. So if you don't find one that suits you, pick another one. Go to 6. 22:12, 22:17. But see how far apart they are there now. They're 5 minutes apart. So that's a launch that took place back in April. So they're much farther apart than the most recent launches. All right, so let's pick this back to our we're not going to see nothing from 9 yet because 9 hasn't launched yet. So we'll be watching these two placeholders to see what happens. We can also scroll here. This is the search period starting from the 23rd to 24th. Well, let's go one more day ahead. 24th to 25th. There's the next two placeholders. 25th to 26th. 5, 3.9. So I'd be looking for something here that has a really low number. Doesn't seem like I'm going to get very many low numbers. 3.9 is about the best I can get. That's coming up on the 27th. Starting at an altitude of 10 degrees, only going as high as 24 degrees. So this next launch doesn't appear like it's going to be the very best to watch. As I can continue to scroll through, I'm not finding any that are really that low. Now this one's not bad. There's the 28th, so that's 5 days away. Magnitude. So there we are. There's a little bit better, right? But we're still not seeing the whole thing, and it's going to take place pretty quickly. Again, if I want to go back to, let's go back to today's date, this 21st. And it's kind of because you can just continue to scroll like this and look at them yourself. Let's go back to Starlink 8, and if I scroll ahead, they're all times early in the morning. So nothing's really going to be available there because of the launch time. It took place at 4 in the morning, right? Let's go back to our 21st again. Almost done here. And we'll drop down to Starlink number 7. So here's our times. A little bit more reasonable to be looking. A little bit more reasonable with as far as the sunset goes and twilight appearing. But still, we're not very good in magnitude. So we're gonna click ahead another couple of days, and we're getting into 5. So not much with that one either. So out of the bunch, probably getting up early in the morning with this set. But I would get in here and I would play around and just make sure that you've got your selection up here in the top right hand corner where you are, and you can go in here and play with any one of these. And if you find something again with a low number and a very high altitude, those are going to be your best bets for sure. Making sense?
Yep.
Okay. Hoping making sense to people that are out there watching. I'll go to Starlink 7 here one more time. And we're still seeing, there's our highest point is 17 degrees, 16 degrees, 15 degrees. That's not very high in the sky, right? So they'll be difficult to view for sure. So this is what I do. I go in and take a look here and see what's available before I comment back to someone because they're asking me, can I see the Starlinks tonight? Well, yeah, if you want to get up at 3 o'clock in the morning, you can see them, but they're not going to be very bright, you know, and they try to explain magnitude to people and what they're actually going to see. So So just go in here and play around. This is where I go. Right, it just says Starling passes for all objects from a launch. Again, you can pick any one of these from the drop down, and you can scroll back and forth here, right or left, to pick the day that you want. Now, one other thing we can do though is we can scroll back to our main page, and we can look down at the ISS, because the ISS is also listed here. So here's the ISS, and really no passes until the 28th. So if there's nothing happening in the next 10 days, I believe it is, you're not going to see anything in the sky. So it's right up to from June 21st to July the 1st. So the first pass it has is June 28th. So the next 7 days. So June 28th, click on that date. Let's see what happens. Well, there we are. We got a pass that we would be able to pick up. But again, if we go back to it, it's only 18 degrees high. So we want to look for a highest point here that's up in the air. So here's one here, 45 degrees. And at 45 degrees, the brightness has increased because it's a higher negative number. So here's June 30th. We'll click on June 30th. There's the pass of June 30th. And we can see here, here's Saturn and Jupiter. So it's going to pass right beside Saturn and Jupiter at that time. And again, don't forget to go up to the ground track. And that'll place it right where it's going to pass. So, any questions there before I get off this one? Bridget says seems to be better than the app that I have, so I'll try using that website. Yeah, I do like this one for sure. It is the one that I refer to an awful lot. I'm old school. I like Stellarium on the laptop. I like Heavens Above here on the laptop to bring up the values that I'm looking for. But what I do is I look for the dates. I look for the brightness here. I want to see a very low number. I want to see a very high altitude if possible. And it'll always tell me here that it's the visible pass. And again, all I got to do is scroll over like that, and I'll get more and more dates. So here's a whole bunch of dates in July. All kinds of passes coming by in July, from July 1st to July 10th. Look at them, all kinds. And all kinds of nice bright passes. Minus 3.8. To compare that against something, that's about as bright as Jupiter gets right there, or as Venus gets. So if you remember Venus being in our evening sky, that's about as bright as it gets. But if you follow that one right across, it's coming out of the southwest. It's going to be 71 degrees up, really nice and high. So the higher it is, the more sunlight it reflects, because those solar panels are now pointed back at the sun, and they're reflecting a whole lot of light. And here's the nice bright pass that we'll get on that date. I go to the ground track. And the ground track for that particular date is right there, right over Nova Scotia. So lots of info there, and all you have to do is go in and take a look around. If you're wondering about the next launch on Starlink 9 coming up on the 23rd, if that actual launch changes, or the time changes, if for instance they can't have that launch at that particular time and they put it, say, 6 hours later, well, all of this is going to change again, because the placeholders that they have for Starlink 8 won't be at these particular times. So that's about where we stand for this one. And also, you can also go in here and look for the daily projections for brighter satellites. So if you see something passing over the top and you're wondering what it is, here's a whole list of those as well. So for today's date, here's all of the rockets. All of these are spent rockets that are first stages of rockets that were launched in space. Most of them are spent rocket pieces. Some are satellites that are coming back into the Earth's atmosphere, and it gives you all the dates and times for those as well. Now, they're not very bright, most of these, because they're not designed to reflect sunlight, but they will. Okay. Clear as mud?
Clear as mud.
All right. Let's take this off then, and I'll take this off.
Is Mike? Mike's back. Okay. There was a question for Mike.
Oh, okay. Let's get back here.
Okay.
Hang on.
I don't think it was answered. It's from Richard William, and his question was, is the autofocuser the same as equatorial mount, and is an equatorial mount needed for the focus motor?
No, they're two completely separate things. The autofocuser is strictly so you can focus your optical tube, no matter what mount you put it on, alt-azimuth or equatorial. And of course, the equatorial mount is used if you're doing astrophotography, so you can track across the sky at the same rotation that the stars are moving. And I think a focuser is a lot cheaper than an equatorial mount.
I would say.
So we had one other comment here, Mike. Bruce Kasuchi says, thanks for another entertaining and informative show. Darth Vader needs a more worthy opponent, just saying. So
You
maybe
send one
work
to
on
me,
that.
and I'll put him up there in front.
There you go. Okay, folks, I guess that's what we're going to call an evening now. So in closing tonight, I'd like to thank each and every one of you again for your continued support of our efforts here. We all want to thank you, actually. We want to remind you, too, that we love getting your photos. So, again, you can send them to SundayNightAstronomyShow@gmail.com, and we will put them up on the next broadcast. And my special thanks again to Rosanna Armstrong for her Fun Facts episode. And, of course, Mike and Paul, you guys, appreciate it. For your continued contributions to the show. And I would also like to ask that if you enjoyed the content here tonight, that you please consider giving us a like on the episode if you're joining us from YouTube, and please consider subscribing if you haven't yet. Also, we'd like to share with you that, or if we'd like you to share with your friends and family, that we are live every Sunday night. And again, like I mentioned earlier, we have started a new Shoot the Moon contest again with a chance to win some nice prizes. So all you have to do is capture a photo of the moon and send it in to my Facebook page with any device. It doesn't matter what device you've captured it with. All photos are treated the same. There's no judging going on. And the contest closes on July the 11th with the draw on July the 12th. And finally, I'd like to wish all of you a good, healthy, and safe week. We're hoping to try a new form of outreach for all of us here this week, sometime maybe at Saints Rest Beach. So stay tuned for updates on that, when it's going to happen. We're not out of the woods yet, folks, probably not, at least until we get a vaccine that's deliverable to all of us. So let's continue to wash those hands, practice that social distancing that we are all accustomed to by now. Stay at home if you can, and know that we are here to entertain you each week at the same time. So from now then, from Mike and Paul and I, stay safe, be well, and as we like to say here, keep your scopes, guys.
Line it up.
Line it up.
And
Yes, sir.
Happy Father's Day.
And happy Father's Day. Absolutely. Great.
That turns into a thumbs up.
Perfect. Thanks so much, folks. Pleasure being here with you again. We hope to see you all again next week. Have a great week, folks.
Right.
Good night.